hackathon organizer and one of the most active developer initiative platforms. It creates a global hacker movements and provides toolkits to help developers around the world like team up and fund their ideas and builds via hackathons and bounties and grants and more. So today we have our 4 projects for the second round. So we have Saltivka. Hello, Victor. So and we have the
Hello.
second project called Nostr Space by Henrik. Hello, Henrik. And
Hi,
the
everyone.
third project, yeah, the third projects we have the Nostr Client Relay by Pedro.
Hi, everybody.
Yeah, and the last we have Bitcoins by Xiangjin. Hello, Xiangjin. Not to forget to mention our beautiful judges. So we have as presents our guests fiatjaf, the protocol creator. Hello, fiatjaf.
Hello.
Yeah. Also we
Good
have
evening.
yeah. Good evening. So we have also G, our judges from the previous round one hackathon judge. So hello, G. How you doing?
Hey, good to be
How you
here
doing?
again.
Yeah. Yeah. Good to see you again, man. So also we have Linin from DoraHacks. Hello, Linin. Yeah, and not to forget Alex. Hello.
Hi everyone.
Yeah, hello. So as a start, let me again introduce our team. So we have here as present co-host Yufu and Sean.
Hi, nice to meet you guys.
Hello,
Nice to
Sean.
meet you, Fiat
Yeah,
and the
hello,
team.
Yufu.
It's glad to have you here.
Yeah, so I would like also to welcome everyone. So now we're gonna start by the first project. So Xiangjin gonna present to us in 10 minutes his projects that he make, and then after that we're gonna have like a Q&A from 2 minutes to 5 minutes from our judges. So you ready, Xiangjin?
Yes.
All right, so you can start, bro.
Okay. Before I start, I just want to mention that I am currently on the road, so if I might get disconnected, and if I do, there are resources on the slides where you could take a look at the demo that we have recorded, and as well as our code base, which is public on GitHub. So with that, I'm gonna start.
Hopefully it's not gonna cut.
Yes. I'll just go fast.
Mhm.
So I am CJ. Today I want to talk about Bitcoin. Bitcoin is a project that runs on Nostr. Can you move on to the next slide? Yep. So one of the goals of this project is to bring the health community to Nostr. Personally, one of the complaints I've heard is that the content on Nostr is not diverse enough, although I think that is starting to change. Majority of the clients out there today are still social media clients, and with Bitcoin, we're hoping that we could help diverse that by bringing the health community over. So we want to sort of lure these athletes over to Nostr, and the strategy is to simply giving them a reason to use it. And our strategy is pretty simple, which is to pay them sats if they exercise. So how does it work? There are 3 components. There is the heart rate sensor, the Bitcoin mobile app, and then the trainer agent. So the heart rate sensor will capture the athlete's heart rate data, and that heart rate data gets sent to the mobile app via Bluetooth. And then the mobile app then publishes that data to the trainer agent via Nostr. So once the trainer agent gets the data, it checks if the BPM is above 160 for 12 consecutive seconds. If it is, it will check if the daily disbursement limit has been reached. If those conditions are met, then it will send ads to the lightning address associated to the athlete's lightning address. Sorry, sends ads to the lightning address associated to the athlete's Nostr profile. So that is sort of like the high level overview. On a more technical side, if you go to the next slide, we basically allow the athlete to log in to the app with their Nostr private key. And once they're logged in, we pull their metadata kind0 event, and we check if a lightning address is associated to the profile. If it's not, we allow them to configure it. And for the heart rate data that gets sent from the mobile app to the trainer agent, that is a kind4 event. And once the trainer gets the data and it disperses a set to the lightning address, it sends out a kind3 event, which is a parameterized trace of event. It's updated every time a set is dispersed to the athlete. So this kind3 event is used for tracking purposes, and also we use that to rank all the Bitcoin athletes on the public dashboard that we built. So over the next few slides, I'm gonna just very quickly go through the screens on the mobile app. Here you see the homepage, which shows you the workout history, how much stats you have earned, stuff like that. And then the next slide. Here it shows you all the prerequisites that have to be met before the workout can begin, and we can start dispersing sets to you. You need to log in with your Nostr account, have a lightning address ready, and then share the app to the heart rate device that we support, which is the polar heart rate device. Next slide. Here is where you will log in, and then we show your lightning address. Next slide. Here we show you the Bluetooth heart rate Bluetooth device that is connected. And here, this is where you have all the prerequisites met, and then you would click on the play button, and then that's how you start tracking a workout session. As you can see here, it's showing a BPM of 121. So shows you the duration of the workout and then the amount of sets that was earned. Next slide, please. So right now we have a limit of 160 BPM for 12 consecutive seconds in order to earn one set. This could change. Of course, we just need some feedback from the people. And yeah, BPM of 181 and then 6 sets earned. Next slide. Thank you. So there are a lot of things that could be improved. Some of the fun ones is we're thinking about encrypting the data that was published, because right now it's free for everyone to read. One fun thing we could do is we would encrypt the data, and if anyone wants the decrypted version, they could zap the kind3 event, and then we would send a kind4 event to them with the decrypted data. So in a way, these athletes are not just giving away the data for free. People who want those data, they could sort of purchase them. Another fun one is group challenges. You could form groups with your friends and then do monthly challenge where each of you pitch in sets in the beginning of the month, and then at the very end, whoever is the most active get all the sets. Basically, people gimmicks to make it fun for people to exercise and then make sets, earn sets in the process. And we also definitely want to support more heart rate sensors. That's actually the
Hello, Xiangjin. I'm sorry, guys, for the technical issue. And he is at the end of his presentation, so Xiangji. So as we can see here from the last few slides, his resources. So we maybe save his questions for him to later on. So when he comes back. I'm sorry for the technical issue again. So we're gonna go straight to the next contestants. So I think I would like to welcome Pedro. Welcome, Pedro.
Hi everybody. Last time I did a demo of some slides and some programs. Through that, I do this in a very short way. So this was okay. Let me share my screen first. I share screen. Oh, share screen. Share. Can you guys see my screen?
Yes.
Can you guys see my screen? Yes. Okay.
Yeah, we can see your screen.
Okay, so this was the PowerPoint I showed last time. My project is called Nostr Client and Relay, and it is I call it a C++ engine that allows to build applications for command line, desktop, or web. And so these were the slides that I showed you last time, 14 slides. I made a small introduction telling how Nostr is and why it's important. It's important for me because because of the design itself. It's a very neat design to have this distributed application. Because it's censorship free. Because reasons I explained, there is a video recording of the talk. You guys can go and see what I told last time. And then I want to explain exactly what I did. So I'm a C++ programmer for many years. So that's why I use the language. I'm very used to the language. The source code is available on GitHub. You guys can go get it. So it's an API that allows you to write code in C++. It is an example of a function to make a request. So with a few lines of code, I can do a request. So I define a string with my public key, a subscription ID. I define a filter, and then I call this function called make request, and this function generates this this is a filter in C++, and then the function this JSON here. There's another function called make event. Another function. This is the code of the make event. This is the JSON that the make event generates. This is an event in C++. So it has an ID, a public key, a time, a kind, a factor of tags, the content, and a signature. So this is the API, right? So I can write computer code. I'm going to show you the code soon here in working in action. The actual code with examples. We can go to that. But my project also has actual executable programs. So it has a Nostr client, command line client, and people can run from the command line, like from the command line of the root of my project has several things. And one of them is a client, so I can, what I do in code, I can do online, right? So I can put several options and send or request a message. I also have a web interface for the. So this is mainly for me for learning at this time. I work with JSON a lot. So right now, all my clients work with JSON only, but the future they will show images. This is the web interface of the client. Also, we have also desktop clients. This is the Windows executable. For some reason, I cannot make it to compile right now. When the user builds the programs in a command line, like here, right? I use a build thing called CMake. So I just type CMake at the command line and generates the solution. So, it generates several programs. You guys have the examples, but it also generates the that we can show that another time. But, the actual web client is live. It here live right now on the internet. So I can, how does this work? I have a relay here. I can choose an account or request. I put my private or public key. This is my public key. And then I can the button here, generate message. I'm going to try to generate my list of. Here we go. I generate a request with authors with my public key, the one I got here. Kinds tree means contact and limits. So when I send this, it will actually send to this relay and receive a message. Here we go. Here it is the message I received, all my contacts. I improved this a little bit to get my feed in JSON. If I click here, get feed, it will get my feed in JSON format. It might take a while because here we go. This is my feed in JSON of the people I'm following. Here they are. What they are saying today. Also follow here is another list. We go. This is the people I follow. We can see right now. We can see the main reason I use C++ is because it's a good language to write. You know, it's a powerful language. I can write a solid backend, and later I can do this web page. By the way, it's actually C++. This is a friend to build a web server. So it's a web server. So this is the example running the API. I have here the function called. So I can go with a public key, define the filter, and I can go. We can go actually inside the function. This is the reason I use it first, because we have to have like solid development tools, which in JavaScript we don't necessarily have. JavaScript is a kind of just a language to do nice web pages, but little more, nothing more than that. So this is the function that allows to do the request. And then there are other functions, parse request, parse event. I don't know, guys, if you have any questions, just feel free to interrupt anytime. This is another function to get the list of follows. So basically, that's what I wanted to show. This is the command line client here. Unfortunately, I cannot build the desktop client right now. This is the command line client. It's called Nostr. If I run it, it will. Oops. Not Nostr is the library. It's just the library, and the command line is called Nostr. So if I start it, it will do something. I cannot connect because the relay is not ready. So I have also a server called to do the science and the server at the same time. So I have a relay of Vostro. So I can start the server and I start. If I start the two programs, it will try to connect the server to the client. So this is the server system here. It gets a message from the client. This is what was the client said.
It's
Okay, I'm kind of more or less done on my demo. I cannot see the if you have any questions, feel free to ask.
Yeah, thank you very much, Pedro, for the amazing presentation of the project. So also mention I would welcome the judges, John and Papu, on the on the demo day. So welcome, John and Papu. So I would like to welcome the questions from any.
I have a question. Which what are you using for? So you wrote in there. So you've written a real Nostr. Is it called?
Are you asking this for me?
Yes.
Sovereignty.
Yeah.
Yeah. Okay.
Yeah. So you wrote a relay implement as well.
Yes.
Yeah.
Yes.
What are you using to handle website connections? Using an existing library, or did you write something?
Yes. Yeah. It's not implemented from scratch. I use a separate library called server. I can show you. We can show the screen again. Since we got, I can go. If I go to the examples again, I can show you the socket running. So step in. Let's see this again. Actually, the actual code. So I have a function here called relate to. Okay, let's try to see here. So I put the breakpoint. Relate to. I have the socket is server LOL, and let's see what happens inside the relay. This is the actual socket code. So it's called WSVS client. The beauty about Visual Studio, we have total control of the code. That's the reason I do C++, and I couldn't do this in Visual JavaScript. This is the actual library code, and I can go inside. So this is on message, means I got a response on open, on close, on error, and let's see what happens here. On open, the breakpoint, it means my client, it means the server got my request. On message here, I'm going to send this JSON here, which is actually this is the response I got. This is the actual feed of my followers. You can see the actual string here. I got a couple of messages and now on close. So this is what my function returns. This is the actual response from the server. So it's pretty cool to do everything in C++, right? So I have it like total control of the program. I don't know if that answers your question.
Yeah,
So,
that's okay. I'll have a look. That's good. I'll have a look at the at your code. It's all on GitHub or somewhere.
yes, it's all on GitHub. So my slide, if you go to my slides that I sent last time, on my first demo, it has here the GitHub, and I can actually show I'm sharing my screen. Actually, I can. Why not? I can just show everything. So I got here bookmarks here. So if you go to GitHub, it's called Nostr Client Relay. My name there, and here we go. Here we go. So it
Yeah,
has
you
some
can
instructions.
just
Okay.
put the link on the Telegram group, and then he's gonna look at.
Okay, understood.
Yeah.
Okay, if you guys
So
have
any
any
more
more
questions?
questions,
Yeah, any more questions
Yeah,
from?
oh, sorry.
Yeah. Okay. Welcome. Go ahead.
Yeah, I have a question. Could you tell me, please, do you have any plans on packaging your Nostr Relay in some like standard or convenient way, say Linux package or Docker? Because since C++ may be pretty efficient if implemented correctly, it may be very beneficial for other developers to say install your package like Nostr C++ client and say generate messages from the command line in just Bash or something like that. So do you have any plans like that?
yes. Right now it runs on Windows, Linux, Macintosh. I try to write all multi-platform codes, and it runs on iOS too. I have actually I could show you my mobile desktop. Like 2-3 minutes for me to show my mobile client.
Yeah,
I mean, you
we
cannot.
we just running on time. Maybe you
Okay,
can get in
okay.
touch with Victor, and then hey, the rest of the information. So,
Okay.
any more questions from the judges? Maybe Fiat or John or Pablo? All good?
All good.
Yeah. Okay. So, I think no more questions from the judges. So, Pedro for the presentation and for answering some of the questions. Thank you. So.
You're welcome.
Now we're gonna move to the next contestants. So we're gonna see Victor's project, Vilska. I think I spell it right. So Vilska, you can share your screen and then start presenting. You have 10 minutes and 5 minutes of question Q&A. So welcome.
Yeah, hi everyone. My name is Victor. I like the core idea of Nostr, and I think to actually achieve it, Nostr requires a lot of relays. Currently, it's around a couple of thousand, but I'm talking about something like hundreds of thousands or even millions. To address this issue, I'm working on a so-called friendly relay implementation that is primarily aimed to satisfy needs of client developers and relay operators who want to run small to medium services on Nostr. However, if one wants to use this implementation for a service with thousands or millions of users, it should be possible, maybe with some extra cost for hardware, since super optimizations are not the first priority. Current state of things there is that this relay implements all the server-side MIPS, including some experimental, for example, like MIP for discrete fast authentication. It's live on a moderate hardware setup. I have some basic benchmarks which I'm personally satisfied with, and I'm going to publish results as soon as possible. It seems to be there are some real users on this relay, but more testing is required, which will help to find bugs and optimize performance for complex queries. The main mission I see for a friendly relay implementation is to give client developers and relay operators a chance to explore different monetization models so that decentralization would be sustainable. Today, since we are limited on time and many features are still work in progress, I will show you how to deploy this relay implementation in 10 minutes without touching any code, and we'll also look at some of the existing features. So to start, we have to sign up to DigitalOcean in this our demo example. Then we create a server called Droplet here with a predefined image called Caprover. Okay. Caprover. Caprover is a platform as a service, self-hosted platform as a service, which is basically technically UI, a super advanced UI to Docker Swarm. So we create this image. We then wait until image is created. Here you can see I have already created the server so just we don't waste time on it. But I hope you will believe me that I didn't do any black magic or coding behind this, and it's just a simple server. Then when the server is created on DigitalOcean side and Caprover is finished installing, we have to copy this IP address and point our domains to this address in order for Caprover to work correctly. You can see demo and the wildcard demo domain and demo domain are pointing to this IP address. And after that, we log into this dashboard. We make some simple preparations like pointing.
I can only, sorry to interrupt, I can only see the text editor.
Okay, that's what I was asking for. Thank you. Is it better now? Can you see?
You know, we can only see your
No.
notes, but we cannot see your demo itself.
Sorry, my what?
I think you're sharing the wrong desktop, maybe.
Got it. Got it. Sorry, give me a second. Where is it? Yeah, stop sharing and show a proper screen. So this should be this, right? Okay, we won't start from the beginning. First, it should be here. It's a GitHub with implemented NIPS. Can you see it right now? Is Zoom okay?
Yep.
Yes.
Sorry for that. Sorry for that. So this was the beginning, the GitHub with existing NIPS. This is GitHub UI. We create a server. We create an image from marketplace called Caprover. I have already told you what Caprover is. We wait until it's ready. You already saw my text. Maybe you have finished it. So we set up a domain. Here we make some adjustments like pointing our domain as a root domain, enabling HTTPS, and our server is ready with our Caprover, and we are ready to deploy our relay. Here you can see I have already deployed one instance, just in order if something goes wrong, we have something to see, but I suppose everything will be okay, and we will deploy another instance. So next we have to add one-click application. These are the applications that Caprover team and Caprover server allows you to install by default. Our image is not here because it's not yet a part of official Caprover GitHub. So we have to add our custom repository, think of it like Linux repositories or anything else. So we add a custom repository here, and we are able to deploy our application by reloading the page, seeing it here. In future, I suppose when I will get to a stable version, I will make a PR to Caprover, and it will be available by default. So we deploy our application. Here you can see some of configurations. Most of them can be skipped for now. We only need application name and admin email. If you want to see so on GitHub, you can see a complete list of configurations. But for our purposes, we will go with default. We will say that it's something like Saltivka. And let's use my email, and that's all. Let's deploy. Instead of deploying, while we are waiting, let's go to the UI of deployed instance, just not to waste time, and then we will check that everything is okay. How do I remove this? Okay. So here you can see the deployed instance. Okay, we can do it like this. Here is up. Here is up. We can go here, and here our URL. We go here. I'm already logged in. User was created by the system. We can find its auto-generated password here. We won't relog in to not waste time. So here is our admin panel. Let's start with a profile, what you can see here. Pretty simple for now. We can confirm our email. We can connect APIs. It will be used in future to properly manage your paid subscriptions. You can connect it right from here using NIP7 authenticators if you don't have NIP42 compliant clients at your hand, something like that. You can also generate a URL to connect to the relay which is protected with NIP43 authentication, even if your client doesn't implement NIP43. Here you can generate a URL and connect to your client, and it will use correct authentication method, but we probably won't review it now because it will take some time. Next, let's go to here. We have trusted pub keys. It lets you manually add pub keys that will be authorized at the highest level in the system. You can write about current implementation authorization levels and how it's supposed to work now and in future in the GitHub repository documentation. What else do we have? We have subscriptions. If anybody would already have paid some pub keys with some money, you could see it here. You can also manually add a specific pub key, like you can top up its period with some amount of days. We also have configuration. Here it shows you environment variables which are used during deployment. Here are some environment variables and settings you can configure on the fly, like turning on maintenance mode, setting IP addresses that won't be subject to rate limiting, allowed connections number you can change. In future, I'm planning to move most of these configurations into this part, which will be adjustable on the fly, but now it's just requires reloading of the application. Next, Sidekick is technically it's just a library that allows handling queues on the technical level. Here you can monitor it and see how it's going. It's not so interesting. What interesting we have, there is a relay mirroring system. It allows you to synchronize events from your chosen relays that are coming in like real time, and you can also synchronize past events from specified relays. So here we can for example, start mirroring events from most.low. After a couple of days, you will see that events are coming. We can add any relay here. So we can first populate our database using past relays, past synchronization, and we can also have some sort of synchronization of future events from other relays. If, for example, you want to make some analytics on events, or maybe you want anything else. So you might have different reasons to have a database full of events. And here we can see, so here it's leaf. So events that are coming to Nostr.low are copied here. And here you can just, to ensure that it works, you can, by reloading the page, you can see that here is the latest events on our relay. What else do we have? We can go to, we can check this quickly. So let's deactivate synchronization. You can see that it stopped. Latest events are not coming. Let's use Iris2 client to connect here. You can see here is my client. Here is my network settings. We can keep removing it. Here is my relay. We create a message test, and we go back here, and we should see it in the list. But whether something goes wrong, let's check it one more time. No, it's here. So we ensure that it's working correctly, and it's not just a prepared instance that does some magic. What else we can see? Oh, and the next thing that we can see is connection management. Since we connected from our client here, we can see this connection in this screen. I'm not sure it has a big value in production usage, but maybe it can be used in some debugging process or anything else. And it may be interesting to see who is currently connected to your relay and how much traffic they used, etc., etc. We closed our client, we lost connection. And the last thing I would like to show is that it already has some sort of very simple HTTP API. For example, you can go here, this ID, and find this event using the regular HTTP API. And here you can emulate like request query. You can do it like this if you want to filter and like send regular req event here, or just specify filters like this in the same way as in Nostr protocol. Why do I find it useful? Because for testing and some integration purposes, HTTP API may be more convenient, and also a lot of workflows more convenient to develop using HTTP API. So maybe in future, if I finalize it and submit it as a new need, some relays will be able to choose which workflows to execute through WebSockets, which workflows to execute through HTTP APIs. So that's basically all of the features available right now. I want you to understand that the main concept of this development is to make it feature-rich, usable, user experience easy, etc., so that everyone with different purposes would be able to deploy their relay and play with it and explore different ways of monetization, so that we would have a definitive answer. Why should I run a relay, for example, or why should I develop a view client? Something like that. So now let's finish with ensuring that our new instance was deployed, and we were really able to deploy new relay in 10 minutes. Here you can see some final instructions. Let's follow them. Here is our new instance. We just enable HTTPS for that. Wait a couple of seconds. We force HTTPS, allow WebSockets. It's all related to caprover thing. Of course, there are millions of ways of deployment. Next, we take auto-generated admin password, and we follow this link. So here our new instance of relay. We use our admin email, and we use admin password. And here we have brand new relay running. We can start synchronization. We can share a link, etc. So to be short, that's all. Would be great.
Yeah, I think the time is surpassed. Yeah, thank you. Thank you
Thank you very much.
Yeah, thank you for the presentation, Victor. I would welcome for the Q&A from the judges. So if the judges has any questions, I would like to welcome you and ask Victor for it. So anyone? Maybe G, John, or Pedro?
I only have one question.
Yeah.
I'm just curious, what relay are you using underneath?
That's my own implementation. So that's a new relay implementation. I will share a link in the chat right now. So here it's GitHub.
So I have a question.
Yeah.
What do you think about exposing? I like the nice UI for controlling everything. I wish I was actually thinking something like that should exist, and apparently you just made it. But how do you think do you think it's possible to make this work in a standard manner so that it would work with other relay implementations? Like maybe
What do you
using
mean?
Nostr events instead of, I don't know if you're
what-
making like API calls to the relay backend, but if we could come up with some standard way using Nostr to communicate between this nice front end you have for controlling the relay.
So do you mean taking this UI and attaching it to Nostr or STR-Fry, something like that?
Yeah.
Well, this specific UI won't be easy to migrate because it's tightly coupled with backend. In general, I think it should be possible, and it would be great if we would have like pluggable UIs. But my project is not aimed for this. My project is it won't spend time on making it universal. It should be tightly coupled with server in order to.
So you're using like. Sorry, I
Yeah.
understand. You're using like a JSON API, or is it like
It's a standard Ruby on Rails application, and it uses rendered HTML in this case, and in future it will be Rails baked with sockets protocol called action cables. So it's a super standard Ruby on Rails application.
Okay, I see. Thank you.
Thank you.
Yeah, thank you, Jeff, for the questions. So if we don't have any more questions, so I would like to let Victor loose. So no more questions. Thank you, Victor, for the.
I had one quick question, but I'm gonna guess the answer, but just in case. Have you, for any reason, tried any type of traffic, like heavy traffic on this? Because I see that the implementation is fully Ruby, right? I'm wondering what the performance looks like.
Yeah, so to answer your concerns quickly, I can say that I'm working with Ruby for a lot of years, and I hear this question a lot of times. A lot of people think Ruby is not scalable. That's not true. As I mentioned a couple of times, it just may make you spend more money on hardware, but horizontal scalability is pretty fine, and actual bottleneck is Redis, and Redis is pretty performant. I'm currently working on benchmarks and making it easily readable and reproducible, and I'll write articles as soon as possible. But what I can tell you right now, my latest benchmarks were I have a very old ThinkPad notebook. I don't know what processor does it run, but it's very outdated hardware. There are 8 gigabytes of RAM and 4 CPU cores. I deployed all of these to this PC, to this laptop, and I ran 10 clients, really quickly populating events. So like, it was 10 millions of events sending to this laptop. It was able to have like something around 150 to 250 events saved per second, and 10 millions of events were processed for something around 10 hours or so. During this time, it was operational. You could use UI, you could use send subscription requests, something like that. Is it quick? Is it performant or not? I'm not going to judge. I'm just saying raw numbers, like it's something around 200 events saved after validation and after everything else on a very old laptop. So that's what I have now. And currently I'm working on better benchmarks with more expensive servers on DigitalOcean with more proper deployment, like separate instance for database, separate instance for Redis, etc., etc. And once I'm ready, I will publish an article and we'll send a link to Nostr chat to review the results. Yeah, thank you very much. This is very
that sounds great.
Good question.
Yeah, we're very interested in that. That sounds great. So the whole database is Redis?
No. Redis is used for, database is Postgres, and Redis is used for WebSockets, and yeah. And in plans, if we just plan some super high scalability, my vision is that we can, I'm writing, so there are actually 2 parts, WebSocket server and like backend servers that work with Postgres. And I'm writing it with the vision that if you want really super high scalability, you can rewrite a WebSocket server part, which is responsible for handling WebSocket messages, validating them, and sending to Redis. So even no interaction with Postgres in the WebSocket servers part. And if you want super scalable instance of this array, you can rewrite WebSocket servers part into something like Elixir, Erlang, or something like that, which is able to handle millions of connections. And in this case, it will be as performant as Redis is, because Redis is the biggest bottleneck here.
Cool, thank you.
Thank you, Victor, for the explanation and for the answering some of Judge's questions. So now we head to the last projects that we have here. So I would like to welcome Henrik.
Hi, everyone.
Nostr Space. Hello, Henrik. So you have 10 minutes presentation, and after that, you're gonna have some Q&A from the judges. So welcome. Good luck.
Okay, thank you very much. I will start sharing my screen. Can you guys see it?
Yeah, we can see
Yes.
it. Go ahead. Yeah.
Okay, nice. So basically, this project is a game that is a proof of concept that is using Nostr to react to events that are happening there. As an example of events that we are using, we can see reactions, group channels created, and also short test notes that are being sent to Nostr. Some of the technologies that we used to create the world of the game were Enable 3D. You can check later what is this about. Basically, helps to create 3D web games using 3JS and Phaser. Everything that happens in the game uses Nostr to send messages and react to it. So the Nostr implementation possibilities are used to define what event the game must render. And as an example here, I will explain what each of these kind will render the game. So the kind 0, that is profiles, will load a profiles base, and the anypub of this profile is converted to bytes to have the position defined. And one that is short test nodes will generate something like bots in the game, intergalactical travelers that were represented by a green sphere. In the last updated, we already tried to start using 3D models. The kind 1231, that is a replaceable kind, when it's tagged with Nostr space position, will allow the player to change his basis position inside the game. The kind 7 that is related to reactions like likes and dislikes from any posts in Nostr will render something that is a red small sphere that moves in fast velocity that kills the player if it touches him. And I call it like antimatter particles. The kind 40 that are related to group channel creations will render a very big black sphere in the game that will represent black holes, and players should die if touches it inside the game. And the last one, the kind 2921, it's an ephemeral kind. When tagged with Nostr space movement, will show current player's position in the game. And when tagged with Nostr space shoot tag, it will trigger shoot from the player that sent the message. When the player logs in the application, a message is sent to this chat created with Nostr chat.io client. And we are still working to start to doing our own 3D assets to represent objects in the game. But from now, we have been taking assets from Sketchfab just for doing a demo. Some of the tools used to do this application were Nostr tools, the study of the Nostr implementation possibilities, This is to check what events are happening in the game. We are using offchain.pub relay to show ephemeral and replaceable events. Sorry, to show only ephemeral events. Replaceable events are being using with other relay. And here we can see that when players enter the application, a message will be sent to this chat. So let's go to the demo. Basically, you have those controls here. You have C to connect to Nostr, W to move forward, S to stop, F to shoot, O to occupy a position, K to send satoshis to developers if you want, I to show and hide instructions, and E to view a profile that you are touching inside the game. When you enter the game, you is being shown as an spectator. You can't be seen by other players inside this game. But when you press C, you will log in with your Nostr profile. In this case, I am using all by extension to hold the profile private key. But if you don't have it, you will generate a ephemeral keys to just play the game. So basically, everything here that is being spammed are events that are happening inside the Nostr. So those spaceships are short test nodes that are being emitted in the relay. And those bases are the profiles that are being emitted in the relay. You can touch it and press E to see the profile. Well, right now it's not working, but I have to fix some stuff here. If you press wall, you should be able to change your base position. It looks like a player entered here. I think it's one of the team members, Suyog. Yeah, he's here. And when I press F, a shoot, can you see a shoot goes out from my player? And if we go in the relay, we'll see that we are having events emitted here related to movement. The tags that I am using, the code, are here. So we use tags to represent positions of the player shoots and everything else that is related to ephemeral kinds and also replaceable. So when I press F here to shoot, if I go fast to check here, I should be able to see shoot at position at some point here. But it was very fast because of the movements of players here. So that's the latest version of this application. Let me just search here the black hole if it loads something. I can't see it now, but sometimes I can. Oh, here. I will not go there because of the velocity. It will take so much time. But basically, this is the group channel created that has been seen in the relay, and it has been represented as a black sphere or a black hole. And that's all for the demo. I also have a video with the previous version that it had not had yet any 3D assets yet. So basically, you can see that you can shoot, and then you can move your base around. I think I didn't represent it in this video. No. But that's all for the demo.
Yeah, thank you, Henrik, for the presentation and for the projects you have submitted. So I would like to welcome any questions from any judges. If you want to ask something, um, G maybe, Pablo or John, Fiat. No questions.
Can you talk a little bit more about how maybe you see in the future Taproot assets being involved?
Well, of course, I forget to talk. I have been testing Lightning Polar. Let me just show here what's about. So basically, I have been testing the latest version of this reg test network of Bitcoin Lite that helped me to do a Bitcoin Lightning network, a demo one, a test network. And I like to test Taproot assets, but only here using the the terminal, okay? And then the next step that I would like to start trying is to connect my Taproot client with the game. So you could see assets inside the game. For example, if you have some non-fungible token, some Taproot asset in your wallet, you could be able to put this inside the game, for example. And basically, I would like to explore assets that are already created and not create my own assets. So any Taproot assets that user has in his wallet could be used in the game for some purpose. Basically, you could put in the game or use it for another purpose. But cool. I still need to explore it a little bit more, okay? Because all I have been doing until now was to creating a test network here with the Lightning, with this Lightning Polar, and then using the terminal inside the Lightning Polar to generate assets. Now I need to know how can I get the metadata of those assets to be able to display other stuff in the game too.
Got it. Thanks.
Welcome.
Yeah, thank you. So if there is no more questions, so I would like to thank you, Henrik, for the submissions and for the projects and also for the presentations. So I think this is it for this demo day. I would like to thank all the projects that have been submitted their projects on the hackathon, which is presented by YakiHonne and sponsored by DoraHacks. I would like to also thank and appreciate the honorable presence of the 4 judges. It's really cool you guys being here and support some of these projects by asking them some questions and all that stuff. So I think also for the audience, I would like to thank you for being here and watching this live stream and for this demo day. So thank you for being here. I think I see you in another. If anyone has any last word, you can share.
Thank you, our judges. I'm showing here, finally. Thank you, our new friend, fiatjaf, and thank our old friend, Big G, Adolf, and John. Thanks everyone and our fantastic project. See you around.
See you the next guys. Thank you.
Thank you all. And our results for this hackathon will be released around in 1 week. And after this release, round 3 is continuously let's drive it. Let's moving on. Let's keep it on. So thank you to all the judges, to Fiat, to G, to John, to Pablo, and to all the projects, and to Isaac, to Sean, to everyone. So this is it, and see you in round 3.
Yeah, thank you, everybody. Have a nice day and an evening. Bye.
Bye.
Thank you, everyone. Have a good week.
Thank you, everybody.
Have a nice one. Bye.